notes, and we were talking about parent functions, and we went over at least 3 or 4 new shapes, because that was the big idea. Functions make shapes when we graph them. And we just want to know, once I've got that parent graph and that shape kind of memorized and understood what it does, then we're going to do some transformations to it, and they're just going to change the shape. So these are what we talked about yesterday. We talked about if we take f of x and then we add k, and they just chose the letter k, that's going to be a vertical shift. It's going to move it up or down based on whether it's positive or negative. If we change the x by adding or subtracting something, and we usually call it h, inside with the x before it makes the shape, that changes it horizontally. Maybe that's why they used h. But you do have to remember horizontal changes do the opposite of what we think, so you've got to be careful with that. And then if we've got a number outside that's being multiplied, that's either going to stretch it or shrinking depending on how big the number is, and then the sign's either going to leave it point in the same direction or it's going to flip it upside down. It's going to do a vertical flip. Okay? All right, so here's what we did yesterday, and I just want you to watch, and I'm hoping everybody thought about this because that was kind of your homework, is to just kind of have this stuff sink in. The most important graph we're going to use this year, and really probably ever, is a parabola. It's amazing how many places this comes up, and we use it in a bunch of different settings. So here was the pattern. I just want you to watch and listen. It had a vertex at 0, 0. And then from the vertex, and again, that's an important part of this, from the vertex, we go right 1, up 1 squared. Again, from the vertex, from that central location, we go right 2, up 2 squared. So that would be up 4. So that's why I'd label that 2, 4. And then I've got this axis of symmetry here. It's kind of a mirror image on each side. And from the vertex, I go left 1, up 1 squared, left 2, up 2 squared. And the reason when we're going left, we still go up, we mentioned this yesterday and some people caught on to this. Well, if you square a negative, you're going to get the same thing that you get if you square a positive. You're going to get positive answers on each side, so that's why it has this nice symmetric shape. Any questions there? We did these 2 problems, B and C, and then we're sliding down here, and you'll notice all of these on this page, I believe, they're all parabolas. So on this one, it's inside with the x. We said it moved it left, and this is what we did, so please watch. You don't have to write anything down because you should have all of this. It moves it left 2, so we locate the vertex, and then we go, oh, I'm going to go right 1, up 1 squared, right 2, up 2 squared. So if I wanted to, I could label this one as negative 2, 0. Right here, this would be 0, 4. From the vertex, I go left 1, up 1 squared, because I haven't changed the shape at all, and I figured out what that central point is. And then I go left 2, up 2 squared. So if I wanted to label a point right here, I could label that as negative 2, 1. Now, if you're just doing a quick sketch, labeling 3 points is really pretty good. If you label 5 on a test or something like that, it makes it perfectly clear to the person who's looking at it that you know exactly what you're doing and how much things have been moved, stretched, shrunk, or anything like that. What you don't want to do is this. So everybody watch one more time and then we'll do some new ones. What you don't want to do is take this original shape right here. Let me make sure I get this right. You don't want to take that original shape right there and go back and say, oh, it does this, and I move every one of those individually. We're going to take that central point, that vertex, we're going to find where that is, and then we're going to build the pattern based off that. Is that okay? Keely?
Would it be negative 3, 1?
Oh, it would be negative 3, 1. Thanks for catching that. Okay, I'm doing too much talking and not enough thinking. All right, so let's take a look at this one right here. This one takes the exact same parent graph, that parent graph of a parabola, and it moves it to the right 4. So we're going to take this and we're going to put the vertex right here. It doesn't change the shape at all. So once we locate the vertex, from the vertex, right 1, up 1 squared, right 2, up 2 squared, left 1, up 1 squared, left 2, up 2 squared. There we go. We can draw the shape really quickly. And we're just going to draw this quickly. And I'm going to label this point, and this point. So you'll see me kind of vary which ones I label every time. This one's negative 2, 4. Check and make sure I got that right. And I'm counting, not doing too much talking. This is 4, 0, because it moved it to the right 4. And then this one right here would be 5, 1, because from the vertex, I went to the right 1 unit, and I went up 1. So right 1 from 4 would be 5, up 1 from 0 would be 1. Everybody okay with that? Yeah.
Would it be positive 2?
It would be positive 2. I'm glad Keely's here and reminding me this stuff, right? Okay. Excellent, thank you. All right, this one's different. Jack, you got any idea what that 2 does?
Dilates it.
It dilates it. That's the fancy word for it. A lot of times we'll just say that this is a vertical change. So I'm going to say that it's a vertical. What word could we use it if it dilates it by a factor of 2? Yeah.
Stretch.
Vertical stretch. Now, when you want to describe something, it's nice to be as precise as you can. So vertical stretch and just write factor 2. So here's what this means. It's going to make it twice as tall. Another way to think of it is, and I like this one because this is going to be really helpful down the road, twice as steep. Question?
I was going to say, because you also say, oh, but never mind.
What were you going to say?
I was going to say it would be half as wide.
You're right, but you can't say that on this one because this was a vertical change. We'd have to do something different in order for that to happen. Okay? We'd have to write it differently. We could make that happen. Okay? So we didn't slide it left, right, up, down, or anything. So the vertex is right here at the origin. We normally go to the right one from the vertex and up 1, but we're going to vertically stretch that. So we're actually going to go twice as far. We're going to go up 2. We normally from the vertex go to the right 2 and we go up 2 squared, which would be 4, but we're going to go twice as far as that. So how far are we going to go up? Not a hard question. Andy, how far do we go up?
For the second one,
Uh-huh.
4.
We normally go up 4, but
8.
8. There we go. We double that, so we're going to go up here to 8. So we go back 1, left 1, up twice as far as normal, so that would be 2. Left 2, we normally go up 2 squared, which is 4, but we're going to go up twice as far as 4, so that's going to be 8. So this is what it ends up looking like. And we're going to label a couple of points on here. 0, 0. I'm going to label 1, 2, and I'm going to label this one as -2, 8. If I wanted to convince somebody on a test I knew what I was doing, I'd probably label all 5 of them. Okay, now I need you looking up here. Have you got that drawn? Got 3 points labeled. Here's what happened, and this, Mason, this is to your point. We did not do this. Watch. We did not horizontally shrink this. We didn't take the points and move them in. What we did is we took the points and we made them twice as tall. We vertically stretched this. So this old point that used to be right here at 1, 1 got stretched up here. This old point that used to be at 2, 4 got stretched to be twice as tall as it used to be. So the best way to think of this is all the points got twice as tall as they used to be. They were vertically stretched by a factor of 2. The graph got twice as steep. It grows twice as quickly. Okay, everybody good with that? Okay, we'll slide down here. We'll keep running through this. So what does the negative do? We're multiplying that graph, all those y values, by a negative. Luke, what does it do?
Flips it over.
Yeah, it's a vertical flip, okay? So we're going to say, whoops, I need to change colors on this. Okay, we're going to say this is a vertical flip. The technical name for that is a reflection across the x-axis. So that doesn't change where the vertex is. The vertex is still at 0, 0. But what does change is instead of going to the right 1 and up 1 squared, we're going to go to the right 1 and down 1 squared. Right 2, down 2 squared. From the vertex, left 1, down 1 squared, left 2, down 2 squared, and it looks like this. Now on this one, I'm going to label all of them. So this is -2, -4, -1, -1, 0, 0, 1, -1, and 2, -4. Caleb, you good with that one? Got it all labeled and everything? Keely, you good with that one? Okay. Wilson, you good there? Okay. Cy, can you tell us what that 1/2 does?
It shrinks it vertically.
Okay. This is a vertical shrink by a factor of 1/2. So here's what we're going to write. We're going to write vert with a period, shrink, and we're going to write factor 1/2. Now, I'm going to call on Mason. Mason, how would you describe this to somebody? What does it do to the graph?
It makes it twice as like narrow or
How about we
half
use
as steep.
half as steep? I'll take that one. So half as steep, half as tall, half as tall. Okay? We're not doing anything horizontally to this. So here's what we're doing. Vertex stays at 0, 0, because if you shrink a height of 0, you still get 0. Over 1, not up 1 squared, up half as far, so that would be up a half. Over 2, normally up 2 squared, which would be 4, but we're going to go half that far, so that's only going to be a 2. And then we do the same thing on the other side. And the cool part about this is once you've got these points over here, then you're in great shape. So we're going to draw the parabola looking something like this. It looks a little bit different. And it is really tempting for people to look at this and say this. Look up here, please. Pause. Just pause for a second. Mrs. Blas, it really did this. It went like this. But this would be a horizontal motion. If you say it got wider, that's not really what happened to the function, because what happened is we plugged in a 1, we got out a 1 squared, and then we multiplied it by a half. We took the y values and we shrunk all of them vertically. So what used to be right here is now half as tall. What used to be right here is now half as tall. Yes, it looks wider, okay, and we could make an argument for that, and we maybe could down the road when you get to calculus or get to at least trigonometry. But what happened here was this was vertically shrunk by a factor of 1/2. So let's label a couple of these. 0, 0, always an important point. 1, 1/2. Let's get at least one of those ugly ones in here. And then this one right here, I'm going to label that as -2, 2. And if you were to plug in, if you plugged in -2 into that function and squared it, you'd get 4. Then if you took half of 4, you would get the +2. So please don't forget this, because this really comes back to bite people if they don't. The reason those points are on the graph is because they work in the equation. And if they work in the equation or the function, then they're going to be on the graph. What we're doing is we're taking a shortcut. We're kind of memorizing the shape and then saying, hey, I know what to do with this. So I'm just going to call on somebody. So be on your toes. Be ready for this. Angela, can you tell us what that 2 does?
It would move it to the left.
You are correct. Left 2. Lizzie, can you tell me what that +3 does?
Move it upwards 3.
Up 3. Excellent. Doesn't change the shape at all. There's no number in front to stretch or shrink it. There's no sign in front to flip it. So we're going to take this and we're going to go left 2 and up 3. So we're going to put the vertex right here. It's still going to open up, and the pattern is from the vertex, right 1, up 1 squared, right 2, up 2 squared. And then the same pattern on the left. You don't need to talk your way through that. You can just think a mirror image here. That's what the graph looks like. And then I'm going to point to this point right here. It used to be the origin, but lo and behold, it moved -2, 3. And then Samar, can you tell me what this point is?
It would be 0, 6.
0, close, 0, 7.
7.
0,
Sorry,
7.
my brain said a 6.
That's okay. It used to be right here. It used to be at 2, 4. Okay. Back 2, left 2, up 3. Ends up right where it should, but counting points is no fun. And then on the other side, this point would be -3. Correct me if I'm wrong. Keely, did I get that one right? Yeah. -3, 4. We good there? All right. Everybody okay? Okay. Can I see? We're going to do this now. Okay. 5 means I got this. I think this is pretty good. 4 is I'm doing okay, but I got a few questions and stuff like that. All the way down to a fist means I have no freaking clue what you're doing. Okay, I'm lost. Okay, so fist to 5. Show me what we got so far. Just hold it up. Fist to 5. All right. Okay. All right. Not doing too bad. Okay, let's take a look at these guys here, and let me just fill you in. Here's what we're doing. We got a half an hour left in class. We're going to do some sketches to finish up this page. Then we're going to do some on the notes, and then no homework other than thinking tonight. We'll finish the notes for 2.1 tomorrow and off we go. So take a look at this one and let's figure out what's going on here. What does that do? What does that do? And what does that do? We're going to go backwards, and I'm going to call on Addie. Addie, what does this minus 1 do? Sorry, Abby. Sorry. What's that? The last one, yep. Down 1. Excellent. Okay. Hannah, what does this minus 1 do? It does. Remember, those changes inside with the x do the opposite of what you think. So this is going to be right 1 and down 1. Okay. And then Megan, what does this minus in front do? Okay, so I'm going to write V flip. Is that okay with everybody? So let's find the vertex. Right 1, down 1. Vertex is right here. And then instead of this pattern going up, it's just going to go down. From the vertex, right 1, down 1. Right 2, down 4. Back 1, down 1. Back 1, down 4. Graph looks like this. Okay, pause for just a second. If I said find 3 points on there and label them, or all 5 points, could you find all 5 points and label them? Okay, so we're going to speed this up just a little bit. We're just going to quickly draw these. So I want you to take a look at this. We won't worry so much about labeling these just in the interest of time. So I'm going to point to this one right here, the -8. And I'm going to call on Brittany. What does the -8 do?
Goes down.
Down 8. I'm going to point to the +2. And I'm going to ask Zach, what does the +2 do?
Left 2.
Left 2. Then I'm going to point to that 4, and I'm going to call on Colson. Colson, what does the 4 do?
Vert stretch by 4.
Ooh, I love it. Caught himself. Vert stretch, and I'm going to say factor of 4. So let's find the vertex. Left 2, down 8. Left 2, down 8. We end up right there. Stretch by a factor of 4. Careful here. Right 1 from the vertex. How far up do I go? I normally go 1. Mason?
You go up 1 squared times 4.
Yeah, 1 squared times 4, so that would be 4. From the vertex, I normally go over 2 and up 2 squared, which would be 4. I normally go up 4. Andy, how far up am I going to go now? 16. I'm going to go all the way up here. Do you see what we're doing here? We are really vertically stretching this. We are making this much steeper. We're not making it more narrow, we're making it steeper. And then if this is the axis of symmetry, I've got a point right here, and I've got a point right there. Those 5 points are going to draw a pretty accurate graph of that parabola. Everybody good? Okay. All right. Who's done I already? Okay. I'm going to give you about a minute. Go ahead and do I. And if you would label at least 3 points on it, that'd be awesome. Bless you.
Thank you.
This has got a bit of everything in it. This is why it has an asterisk by it. It's got every possible combination here. Everything we've talked about. Okay. I'm almost done, but I left it partially completed. I don't quite have everything up here. I'll show you in just a second. What I want you to do right now is think, okay, do I think I kind of understand what's going on here? If he gave me $10 and 10 more minutes, could I guarantee I got this right? Okay, take a look. This is what I have. I went through and I said what each thing does. This moves it up 3. This moves it to the right 4. This is a vertical stretch by a factor of 2, and that's a flip. If I wanted to say vertical stretch and flip by a factor of -2 or something like that, that would be okay. You could combine the two of those together, and this is what it looks like. Now, I haven't drawn it yet. I want to point something out. Everybody watch. If you know that it moves right 4 and up 3, and you can get that point, here's something cool about the labels. You're going right 1 and then right 2. So if you know the x-coordinate of the vertex, the next one's going to be 5 comma something. The next one's going to be 6 comma something. Going the other way, it's going to be 3 comma something and then 2 comma something. So I can fill all those in pretty quickly because I'm not making any horizontal changes to this once I've located the vertex. Over 1, I normally go up 1. I'm going to go down 1 squared, but I double it. So that's down 2. I go right 2 and I go down 8. So if I was at 3 and I go down 8, this is going to have me arrive at -5. And then I can just repeat those values on the other side. That's going to be a 1 and that's going to be a -5. And then I can draw a nice shape of this. Any questions there? Raise your hand if you got it right. Or you were on the right track. Okay, that's pretty good. I want you to do one more thing. Put a dot here, 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 and right here. And then would you draw a dotted version of the original shape? I find this kind of helpful if we draw the original shape on there. Because can you see it got moved right 4, up 3? Can you see it got flipped upside down? And can you see it got vertically stretched, got steeper than it used to be? Everybody good? Okay, all right. Flip the page over. Not quite as much on these pages because these are a little bit simpler graphs. And on some of these, not quite as many points are needed in order to sketch these. So only 3 for an absolute value. I think that's fine. So I'm going to zoom in on this just a little bit. We're going to draw the parent graph again. Again, this is that classic V shape. Goes up like this and up like this. And if we were to label points, they'd be right there. We're not going to take the time to label them. Could you label them if I asked you to or you needed to on a test? So I'm going to ask Lydia, what does the 2 do? Yeah, vertical stretch. And the factor is 2. I'm not going to write it down twice as steep, twice as tall. So here's what's going to happen. Doesn't move right or left. We normally go right 1 and up 1. We're going to go right 1 and up 2. We normally do the same thing on the other side. Left 1 up 1. We're going to go left 1 and up 2. Yeah, you could make the argument that this has got more narrow, but no doubt about it. Aren't both of those sides twice as steep as they used to be? Because it's been vertically stretched. Mason, what does that 3 do on the end?
That's gonna move the whole thing up by 3.
Up by 3. Andy, what does that -3 do?
Inside,
Yep.
it moves it right.
Right. 3. Luke, what does the negative do?
Flips it.
Vertical flip. So we're going to move this to the right 3 and up 3. So that's going to be the vertex. And all we have to do is we're not changing the shape. We're just flipping it upside down. So it's going to go like this. Could you label those 3 points? We're not going to take the time to do it right now, but could you if you were asked? Okay. Parent graph of a square root. Parent graph of a square root. Let's see. That one was the top half of a sideways parabola. 0, 0. That's the central point. Over 1, up the square root of 1. We ignore 2. Mason, can you grab the door? We ignore 2 because that's got a nasty square root. We ignore 3 because that's got a nasty square root. But 4, that's kind of sweet. So here's what it looks like. What does the plus 6 do underneath there with the x, underneath that long bar that's a grouping symbol? And what does the negative 3 do? Left 6, vertical stretch, and a flip. So we're going to take this shape that looks like this, we're going to move it over here, and we're going to flip it upside down, and we're going to make it 3 times taller than it used to be. So that's now our central point. That's where it starts. So we moved it to the left 6. We normally would go right 1 and up square root of 1. We're going to go right 1 and down the square root of 1 times 3. So 3 times taller right there. We would normally go right 4 and up the square root of 4. That would be 2, but we're going to go down 3 times the square root of 4. So 3 times 2 is 6. We're right here. So the graph looks something like this. Would you label that point right there? Keely's going to make sure I got it right. Isn't it negative 2 comma negative 6? And guess what? If you plugged a negative 2 in here, guess what answer would come out? A negative 6. No doubt about it. Because it's on the graph, it should work in the function. Okay? 1/2 times x. Smart. What's that 1/2 going to do?
Is going to shrink it by 1/2.
Yep. It's going to vertically shrink it by a factor of 1/2. So I'm going to put vertical shrink 1/2. So it used to be here, here, and here. That's what it used to look like. Now it's going to look like this. Half as tall as 0, still 0. Half as tall as 1, 1/2. Half as tall as 2, 1. Does it look half as tall? Does it look half as steep? Okay. All good? All right. Cube root. Anybody remember what was weird about that? D?
It like goes in a shape like this. It's like a full parabola, but that at the vertex, like right in the middle of the flip side.
Yeah, it kind of flips. There's some symmetry here. So the vertex, or we need to call it the central point on this one. It's not a vertex, so it's not a corner. So 0, 0, and over 1 up the cube root of 1. We have to skip a whole bunch of points. Where's the next nice cube root? 8. All the way over at 8 before we get to 2. And then the interesting thing is that you can take the cube root of negative numbers. So you can go back 1 and down the cube root of 1. You can go back 8 and down the cube root of 8, and it looks something like this. Again, if you were asked to label this, could you label it? What do the 4 and the 5 do? Jack, what does the 4 do?
Moves it left.
Left 4. Okay. And Gavin, what about the 5?
Up 5.
Up 5. So we're going to go left 4, up 5. Here's the central point. So we'd go over 1 and up 1. over 8. Holy cow, over all the way 8 and up 2. So that would put us right here. And then the other one doesn't really fit on here, so it's going to look something like this. Quick sketch. Could you label it if you had to? Okay, Lizzie, what does the minus 2 do? Down 2. Wilson, what does that 2 do?
Stretches it left center too.
Okay, vertically or horizontally?
Vertically.
Vertical stretch. Okay, so we're going to move down 2. Straight down 2. Over 1, up the cube root of 1, but I'm going to go twice as far as that, so I'm going to double that. Over 8 from that central point. I normally go up 2, but this says go twice as far as that, so I'm going to go to right here. And then the symmetry on these works the other direction, so we're going to go down here, and then about like that. Well, it kind of made it look like it has a corner on it. It doesn't. Okay. Good enough? Could you label it if you had to? Okay. Now, I'm going to pause for just a second. We're going to do notes for 2.1. So here's your thinking homework. What shape are these? All of them. Take a look. Every single one of them. What shape are they? Brittany? They're linear. Could you graph the first one? Hope so. Could you graph these other ones based on transformations? Okay, that's the thought homework that I'm going to ask you to do. We're not going to take time to do that. It's kind of a silly way to graph linear functions, but it turns out that it works just fine. Okay, so take a break right now. I'm going to pause this, and then I'm going to get the notes ready for the next one.